what is a class? Basically a data type that has functions, and of course it has data and functions. And it introduces the object-oriented programming features. It's definitely user-defined because we are creating it. And the data or the variables in that particular class or methods in the class are called what? The members of the class. Yeah. So in our particular case, transmission and other things would be called members of that particular class. And it can be specified as private, protected, or by now you have your own code template. Yeah. So I can get rid of this. And we have the IO space, IO stream, and the namespace. We've got hello world and our return 0. So inside here, we're going to start with the proper code. So let me just jump straight into it. Luckily, the first example agrees with the stuff we've been talking about. So we have a class called car. Remember, C++ is case sensitive. Again, like most functions, open and closing brace. Yeah? Yes? Are you writing alongside me? You're going to ask me a question if it stops making sense? Yes. So in the class, we have a keyword called public. Now we do something very similar to Python, right? If you have a for loop or something in Python and you start with a semicolon, the rest is what? Indentation, meaning everything under that particular, under this particular word or semicolon is actually part of the keyword there. Yeah. So public simply means that other functions outside the class can actually access it. So it can be accessed by, yeah. All right. So we want to have public similar to global variables, but not necessarily, as long as you can access through the object of the class. So it means that these variables can be accessed through the object of the class externally. Right, so I have string, and we call it brand of the car, and then we have another string, and we will call it the model of the car. And again, it's C++, not Python, so semicolons, and then we will have our year. So far, this is how we say banana publicly. Now, all we have now is what? The blueprint. Yeah? So we have to decide we want to create an object of a car, because you just say, I don't know, I want a car, what car? You can't necessarily, I don't know, you can't necessarily say live on a map that's drawn out, the architect's map, right? You can't live on the architect's drawing. The building needs to be created, yes. Okay? So we need to create an instance of that particular class, and we can call it keyword. This is the class we've created, and we can call it car object 1. I'm just following the same syntax of the code that we have. So we have the first object, and the object, we need to, do you remember the access operator for a structure? Yeah, the struct is a keyword. Sorry, somebody said something online.
I was saying the struct.
So the struct is the keyword, but then we have the struct data type, and then the structure has different variables as its members, right? Remember how we access the members of the structure? There was a special symbol, which we call member access operator, full stop. It was a full stop.
Yeah, it's like right these dots.
Yeah, because dots, I remember I said it's like a doorway into the, yeah. So in this particular case, we've got the object. If we want to access the members of this object, remember we have only declared this, we've not initialized them. All right. So at the moment, we've created our Ferrari and we want to think about how many doors the Ferrari should have and all those kind of things. So remember, this particular instance, it's not all of it, it's just the type of that data type. Yeah. So we have a new object, which, or think of it as a variable anyway. So we can call it car object 1, and we want to access what the brand. And then let's use something that is so easy to spell, BMW. And we can have this way we say things I don't really know what they are. The model of a car. It's a X5, apparently it's a car's model. And let's pick the year. And the year, I will give it, I don't know when X5 was made, so let's pick whatever is there, 1999. Does it make sense up to this point? All right, so here's the challenge, right? Here's the challenge. I want you to create an object called car2. A car object 2. Sounded like cartoon. I want you to create an object called car object 2 of type, the brand should be Ford. And also, Ford has a Mustang.
Yes, Mustang.
Model, Dutch model, and the year
1970.
1970. Let me know when you are done. Of type car object 2, and car object 2 will have a model dot.
But we're not printing it.
Model, no, we're not printing anything. Model equals Ford, and again, car object 2. So we go to the model now. The model is Mustang. That shows how much I know about cars. And the first one will be brand. And this one will be year. Oh, semicolon here, sorry, to complete the class. Yeah, after the class definition, when you close it, you need a semicolon, quite similar to a structure. So I'll do a C out, and I'm just going to say car object 1, and I'll print the branch, and I'll leave a space, and I'll print the model and the year. So car object 1 dot model, not Mustang, and then I'll print the year as well. Actually, we can just do this \T because we've not used that in a long time. And then we can print the year. What am I doing? Let's use this. And we can, of course, print end line here. Semicolon, and I'm going to copy all of this and repeat for car object 2. Basically, remember access operator give us access to the value of this particular object, yeah? And we've made it public so we can access it externally. So we've got basically the brand for this particular object, which is the Ford, And then also we've got the model, which is Mustang, and then we've got the year, of course, the subject to 1970. So I'm just going to run the code. Hopefully it won't complain. And you notice that it's printed them out in the value of these particular objects that we're looking for. So I'll give you some time to type the code from your end in order to fix it. And what do we call the box? What type of, what keyword do we use to call it? Is it a structure? Is it an integer? Is it a class? Is it?
It's a structure.
It's a class. Yeah, it's a class. And classes are like what? Blueprints. Yeah, think of it as your own data type. So we have created our data type called class. And earlier we have to remember that we need to put semicolon, else it wouldn't work. And then we have public members, which means that as long as it's accessed within the scope or the scope of a particular object, then you should be able to have access to these outside the class.
My question is, like under this class of box, you know, we have public, like under it, can we have private and have an
Yes.
set of?
Yeah, but not a subset. Private, not private. Inside the class, inside the class, you can actually have private, you can have protected, and you can have public. At the moment, we focus on public. Yeah. All right. So in there, we've got what? Well, 3 variables of type, of data type. What data type are they?
Length.
Of data type, double, right? And then the variables are the length, the breadth, and then the height. Can I check? Box has what? The length, the breadth, and the height. So if at this point, what are we doing? What do we call this particular box 1 is something of type box, an object of the class box, right? So we have the box 1, box 2, and then we create a variable called volume and then assign it to 0. So this is the member access operator. So if we take the box 1 object at this point, we are simply setting the height to 5, setting the length to 6, setting the breadth to 7, and we do similar to for box 2, and we calculate the volume in this particular case, similar to the way that we printed them out or we copied them out. We just volume is what? The height times the length times the breadth, and then we print it out on the screen, and then we have the same for the second one, and we print it out on the screen. Does it make sense so far? It's a lot easier to understand because it's quite similar to the car class we create. So far, we've just put what? Public variables. Yeah, we want to put a function, and we can have a function that returns a double number, and the function is what? Volume. So let's call it, this volume takes nothing. And we can say it returns the box's volume. And because it's returning something, let's call it get, right? So let's make it a getter. So it gets the volume. So get volume, for example. If I run it, we shouldn't give us an error unless maybe something went wrong. So at the moment, we have just basically declared. So basically, we've added a function. Before, it was just what? Some variables that we had. So we've added a function, and we can actually add how this function works at this particular point in time, but we've just left it, and we know that, of course, it kind of worked because it's not, well, at the moment, the function does nothing, right? But it's not giving us any error yet. So let's say we go a bit more, and we have something called the function scope operator. So let's have something at this point where we can give the full definition of the function. And what was the definition before? I'll copy that, comment it out, and we can get rid of this and put that there. And because at this point, we've not created any object, we can get rid of the object because it's just a blueprint that we are working with. And remember the variables, the length, the breadth, and the height are all public anyway. So we can, and then also the function that we have created is sort of pretty much in the same room. So we can talk to each other, right? So you can access the member variables. Yeah. Does it make sense so far? Yeah. So I will run it again to see whether it complains at this point. Hopefully it won't complain. Why does it complain? Whether the volume is not declared in this particular. Or we can make it easier. We can create double volume and then return volume, but it's just a bit, it's a bit not efficient. Let's see whether it complains now. And good, it's not complained yet, but it's not printing anything. So let's see, well, it's probably printing something for the first and second. But let's do it for the first one. And we can do, because we commented out this, and we can do dot get volume. And yes, it returns the volume of the first box. And we can do the same here. To return the volume of the second box. Right, so here's a bit of chatter. So do you remember when we did, when we accessed the members of a structure and then we used the member access operator, which was the full stop? Yeah, try to access a member of a structure that is a pointer. We use the arrow operator.
Yes, sir.
Yeah, it's just different access operators for different data types. Okay, so at the moment we are using the dot. Hopefully those online can hear as well. We're using the dot as a member access when it is a variable. Okay, but if we have a function, we need the scope operator, which is 2 columns, to get access to a function that is a member of a class. Yeah. That's the only addition we had, thing that we add into this. Okay. Now, at the moment, we have sort of declared, we've defined this function using sort of an inline feature. So at the point where we declare the class, and then we declare the function get volume, we also define what the function does. We don't always have to define it. We've got this definition there, but we don't need to define the function when we create it. We just need to declare it. Define the function when we create it as a member of a class. How then do we say that's banana? How then do we actually define it afterwards? Okay, so that's the code that we'll be looking at this point. And I just want you to pay attention to that part, even though I'll be sort of transferring a whole block of code. Well, let's try to run it to see if it complains first. Good, it doesn't complain. Let's see what the code is doing. As usual, arrow stream and precursor directives and other things. And then we've got a class. All the members are what? Public. And then we have the famous variables that we know already. And we are adding, not mostly like, you know, we've been setting these values and then we've been getting the values of these variables. So normally people or most programmers will use what? The getters and then the setters, or the setters and the getters, setting the values and then getting the values. Yeah, good. So we have the get volume, which is what we have just defined previously, but at this point we're not defining it, we're only declaring it. Yeah, and then we have the set length, and then we have the set breadth, and then the set height. You notice that the setters normally have what parameters or arguments that will be taken. Okay. because you're saying set the height to something. So those take these inputs to them. That's all we have. So we want to go into the box. This is before the main function, please. We say that, of course, we are returning a double, quite similar to the function. It's actually the same function we just have. We go into the class, which is the box class. At the moment, we're not talking about an object. We're talking about a definition. And then we use the scope operator, which is the double column. So it means that we are going into that particular class and we want to have access to a function. So we're just stepping into that doorway into the box class, and we want access to the get volume. And at this point, we are defining what the volume is, which is return, the length, breadth, and other things, which is what we had, right? Then we're doing the same for the setters. So again, we use the scope to go into the box, and then we take the length, which will be assigned to us, and we assign it to what length, right? But because these are members that belong to the particular class, they can make changes to these variables. Makes sense. And we do the same for the breadth and then the height. So we have an object box 1 and another object box 2 created of type class of type box, and then we set the length, set the breadth, set the height. We know how they work, and we get the volume assigned to volume, and at the same time we print it out. Does it make sense up to this point?
Yes, sir.
Yeah.
Sir, one question.
Please.
What you did, what you wrote on from line 15 down to line 21, we can also apply it to within the class. Like,
yes.
Here with.
Yes, you can apply it within the class, but you don't necessarily, then you wouldn't need this because you're already within the class, just as we did before. So just as we did before, just before this line of code, we did this. We did this. You remember?
Yes.
So that works
Yes.
straight away for us. So we're saying that you don't necessarily have to define the class when you write it. This is the most common practice you will see. Most people will write the functions outside the class, so the class does not become too big, right? So if I look at the class, I can straight away tell this class gives me some, I don't know, some variables, 3 variables, and I can make use of some functions. If I want to change the definition of the function, then I go into the function itself to change it. Quite the same as setting the definition here. So this means that we are actually inside the box function and we want to give the definition for this particular function. And because we are still inside the box function using the scope, we can get access to this length and breadth and height without going through anything. At this point, we've not created objects for it. So we have the set length, we take the length and we pass whatever the argument to the length. The set breadth, we take the whatever we're receiving, we pass it to the breadth. We take whatever we're receiving, we pass it to the height. And in the main function, we make use of these particular functions that we have set to set the volume, set the height, the length, the breadth, and the height, and then to calculate the volume, and that will be returned to volume, and we print it out. Does that make more sense now?
Yes, sir.
Thank you very much. So I'll pause the recording. I'll stop the recording here.